Hello everyone, welcome to the class. Just give me one moment, I'll check if I'm online. Alright, so today's class, we're going to see all about friction, okay? So this class may not be long, it is also going to be a class which is going to be very simple, alright? And as and when we learn all the concept, we will try to solve few numericals associated with this as well, okay? The next few classes, we will actually give more focus towards friction, and in the next few classes, we will solve more numericals on friction as well, alright? Now, whenever let's say you take any object, just slide it, right? Keep it on some surface, on table or any surface, just slide it, okay? The object will anyway come to stop, right? What is making that object to come to a stop, right? That's basically a friction. That's what we're going to learn all about in today's class. Alright, so on that note, let's begin. My name is Mohana. I'm a physics educator here at Unacademy. I'll be taking the class 11 and 12 physics. Now, before any class goes live, I will actually share the any update we have also. I'll be sharing in my Telegram channel, so you can follow me on my Telegram channel, as well as this is the common ICSE and ISC board channel link as well. You can follow this channel as well. And next is like how we have the free classes on the YouTube platform. We also have some free classes on the Unacademy platform. Okay. Now, those classes are absolutely free. So we call them as special classes. Now, you can engage with the educators via pool features during those classes. And if you have any doubts, those classes are also live classes like the one happening right now. So you can get your doubts cleared then and there. The link to the upcoming special classes are given in my description box, right? So you can just click on class 11. It will take you for the special classes that are going to come on this month, all right? So what you can do, you can just click on the course. You can register for all the special classes. Over there, you can just click on notify me. So before any class goes live, you will get the intimation. Now tonight, right, at around 7:45 p.m., we actually have a class for class 11, and this particular class is going to be from the same chapter that we're going to take, we are doing right now, dynamics, but it's going to be all about laws of motion. Now, yes, this topic has been a continuation of the previous classes, but don't worry, today's class also we will be learning something new, and it's okay if you don't know about the previous sessions, because concentration more will be given towards Newton's third law of motion and some interesting examples associated with it, okay? Also, if you have any doubts in laws of motion, you can ask me in today's class. So you can join the class around 7:45 p.m. and the class duration is about 1 hour, okay? So click on the link in the description box and you can take you to the class. Also, my Telegram channel group, I would be sharing the class link as well, okay? Now, the next class after that is going to happen on your Unacademy platform is going to be on 27 July at 7:45 p.m., okay? And this class is going to be on quiz on a motion in a plane, okay? Motion in a plane this is the unit 2 where we learned all about vectors. So there's going to be a quiz on that. Don't worry, if you don't know any concept, it will be a very good way for you to revise this concept, joining in this class. So you can join for this class as well. Now, if you're interested with the plus subscription, these are the benefits. One is you can learn from the comfort of your home. Now, whenever you take a plus subscription with Unacademy, you're getting 4 subjects, that is physics, chemistry, math and biology. All right. So you're getting 4 courses and you're getting unlimited access to all courses. Okay. Now you'll be learning from top educators, as well as in case if you have any doubts, okay, every 4th session, let's say first 3 classes you're learning a concept, you can ask your doubts then and there itself. You can get all your doubts clear. But the 4th class will be a doubt clearing class, as well as it will act more like a revision as well. If you have any doubts in any concept you've learned till then, you can ask during these doubt clearing sessions. Okay. Now, in the plus subscription, we will actually cover your syllabus, right? Entire syllabus, as well as you will have mini practice tests available for you. Now, we also have live test series every other week. So how live test series works is that if in case you have, let's say like you attempt the test, right after that there will be a session with the educator. Any of the questions if you have got wrong, you can actually learn the right method then and there, as well as in case if you want to learn about the shortcuts, you can learn that as well. Now, for the upcoming courses and batches, I'll give you the details now. Now, if you look at the pricing, now, the longer duration you take a course with Unacademy, the price per course actually goes down. Okay. Now, for 9 months, you have to pay 1,910 rupees. But if you're taking the course for about 1 year, you have to pay 1,153 rupees per month. But if you take the course for 24 months, then you only have to pay 1,378 rupees per month. Okay, this is the per month you're paying for all 4 subjects. Right now, we have an interesting offer going on, that is your 20% off. This plus subscription is available only till tonight, okay, 12 p.m. tonight. Okay, if you're taking a 11 around to midnight tonight. Okay, so if you're taking any plus subscription today, you will get a 20% offer on this price. Okay, so per month, if you see, if you're taking a 2 years course, this is what you're paying per month, means on this you will get 20% off. Alright, so if you're interested in 9 months, this works, this plus subscription 20% works only if you're taking 9 months and above. Okay, if you're taking a 9 months plan, then you have to pay 14,619 rupees and you're saving 2,578 rupees. Likewise, if you take 12 months, you just have to pay 16,863 rupees and you're saving 2,975 rupees. If you're interested in taking for 2 years, then you can pay 28,104 rupees and you're saving 4,959 rupees. Okay, to avail this discounts, and again, if you're taking 1 year and more, you can pay the amount in parts, as well as there is, I think, zero cost EMI as well available. Here you can actually use my code MTIS10, all right, to get this particular 20% off. Right now, if you're in class 11, you have a particular advantage. If you take the class 11 subscription right now, your class 12 subscription is absolutely free. Okay, for that also you have to use my code. For that you can use my code again, MTIS10, right? So you're getting it before midnight. You're taking, if in case you're planning to take a plus subscription, and if you're taking before midnight, you can go for a 1 year course and you will get the benefits. You have to just pay for 1 year, but the second year class 12 is absolutely free for you guys. And top of it, on top of it, right now you're getting 20% off. Okay. Now, the ongoing plus batch for class 12, we call it as Brahmastra. Now, this batch started on July 6th. And if in case you missed any classes, class recordings will be there and you can ask your doubts during the doubt solving sessions, alright? As well as, this course is taught in English. For physics, we meet every 5:15 to 6:15, Tuesday, Thursday and Saturday, right? And for math, Rahul sir will be taking, chemistry, Manisha ma'am will take, biology, Lakshay sir will take, okay? Every day, there will usually be 2 classes. One is, every day, like every Tuesday, Thursday, Saturday, you will have chemistry followed by physics. And every Monday, Wednesday, Friday, you will have math followed by biology. Alright. Now, if you take in a month, there will be at least 10 classes at least for each of the subjects. Okay. There will be more than that, but minimum of 10 classes at least. Right. Sometimes you have up to 12 or 13 to 14 classes in a month for each subject. Okay. Other than this, there are practice tests available, and as well as you have your the live test series, after which you will have the analysis session with an educator. Okay, so these are the benefits you're getting if you're taking the plus subscription. Now, in case if you're interested to take the class 12 subscription, we have the Achievers batch for that, and you can this course also started on July 6th. For physics, we meet every 5:15 to 6:15, Monday, Wednesday and Friday. Alright, on this note, let's start today's class. So, today we are going to learn all about friction. Okay, now friction, if you see, let's say there's a table. Okay, on the table, let's say we have kept an object. Alright, now this object is going to be stationary, right? Now, if I apply a force, right, let's say I am pushing this object in actually this direction, I'm applying a force, right, in this direction. Okay, then what happens? The object will start to move in this direction, right? This will be the direction of motion for that, for this block. Okay, now if you apply a force to a particular object, depending on how your surface is, right? Let's say in case your surface is very rough, then your object will move only a very small distance, right? In case it's very smooth, it will move a little further distance than that, right? If it, let's say, if the surface being very smooth, the object is only rough, the object is only moving to this point over here. But let's say if it is very rough, it moves only from here to here. But when it is very smooth, it might travel a longer distance, right? But there is something that is making this object come to rest, right? Now, that particular force which is making that object come to rest is your friction, and it is acting in a direction opposite to this opposite to the direction of motion of the object, right? So whenever a body moves, it tends to move over a surface of another body, meaning let's say this block is moving over a table, okay? A force comes into play which acts parallel to the surface, right? See, there is a force, this is the surface and the force is acting parallel to the surface, okay? Parallel to the surface of contact between these two objects, and it opposes the motion of this block, okay? This opposing force is what we called as frictional force. Alright, so very simple concept. Let's say you have a table, you have a block on the table, you're applying a force, right? This will be the direction of motion, right? Or the force on this direction, right? Your force of friction will always act in the opposite direction. This will be your frictional force, right? Now, let's say you have the same ways. Let's say you have the same object, right? This time you're applying the force in this direction, meaning you're applying a force and the object starts moving in this direction. Okay, this is your direction of motion. So this is the direction in which force is applied. In the direction of the force is the direction of motion of this object. Okay, if this is the direction of motion or the force that is applied to the object, if it's in this direction, its friction will always be an opposing force which brings this object to rest. Okay, so frictional force will always act in the opposite direction to that object. Alright, such a simple concept, right? Now, whenever we are talking about friction, okay, friction is actually a component of contact force. Okay, now let's say we have a surface. Okay, let's say we have a surface, right? On this surface, if there is an object, right? Now, according to Newton's third law of motion, this particular block is going to exert a force on this table, right? Let's say this is a table and let's say this is a block, right? Now, this wooden block is going to exert a force on the table, right? So, there is a force acting from the block to the table. Now, this table is going to exert a force on this block over here, okay? So, according to Newton's third law of motion, when two objects are in contact, there is going to be a force that is acting on each other, right? Force because of the block on the table and force because of the table on the block. Now, this is basically your contact force. This is your force. This force F is nothing but your, let's say this particular force is nothing but your contact force. Any object that comes in contact is going to have this contact force. Right now, let's say you have kept let's say you've kept your laptop on the table or your book on the table, right? Or any coffee mug or any mugs that are kept on the table. The mug or your laptop or your book is going to exert a force on the table. Now, the table will exert another force on the book, right? Now, these two forces are actually same magnitude or acts in the opposite direction, okay? Now, this particular force, if you say, we can say this particular force is because of the contact force. Alright, now this particular contact force can be resolved into two components. Okay, one component will be for a force that is actually acting on one component will be basically a force acting along the horizontal, right? This horizontal component of this contact force is basically your frictional force, okay? And then you're going to have another component over here. This is your normal force. Okay, this is nothing but your normal force. Okay, in this case, if the force is in this direction, means again you will have the frictional force in this direction, normal contact force in this direction. Resultant if it is the opposite. Okay. Now this is from parallelogram law of vectors, right? You have towards the, let's say, take the shape as a parallelogram. If this if this particular force is along the diagonal of your parallelogram, then you can resolve these two sides to be like, along the friction force along the x direction and your normal force along the y direction, right? So you have two forces, one is along the horizontal component and the vertical component, right? So vertical component, in this case we call it as normal force. The horizontal component, the component which is parallel to the surface over here, right? That is actually called as a frictional force. Okay, the component parallel to the, so we can say the component the component parallel to the contact surface. This is actually called as friction. So this is the table surface. This friction, there is a component that is going in this direction. This will be your frictional force. Okay. Now, now this is again, as I told you, this is basically your normal force surface. So any object that is, whenever you say there is an object that is on, let's take any object that's on your table, right? So there will be two forces acting on it, right? One is if it is in contact, if those two objects are in contact, one is the force that is acting normal to it. This is your normal force. Another is a force that is acting parallel to the surface. It can be in this direction or it can be in this direction. Doesn't matter. That depends on the motion in which it's going to travel, right? But there will be another parallel component parallel to the surface over here, which contact surface over here, which is called as friction. All right. Now, what is this origin of this friction, right? We have seen what is the frictional force, right? Now, what is the origin of this frictional force over here? Now, whenever you look at a surface, right? Let's say this is the table. On top of it, a book is kept, right? But now, this particular table and this book, if you see, it will look very smooth. But if you use a powerful microscope to view to look at how the surface looks, right? This particular surface, if you see, though the contact area for us, it looks like large, right? Now, for us, if you see through the microscope, this actual point, see, this point over here, this point over here, and this point over here. These will be the actual area of contact. Okay, though this entire surface may look like the apparent area, right? Though this entire surface over here that you're seeing may look like the may look like the apparent area over here. Whatever you're seeing, all of these may look like the apparent area, right? This whole thing, but there's only small portion of it which is actually in the actual contact of the area, right? Now, this particular actual area of contact is very, very, very small, okay? And the pressure at all these points are also very large, okay? Now, the molecular bonds, there will be molecular bonds formed at each point of contact, okay? And when you pull one of, let's say this is your table surface and this is your book. Now, if you pull one surface on the other, right, these bonds tend to break, okay? So, what is happening? If these bonds are breaking, means the material is getting deformed, okay? Now, as the material gets deformed, what will happen? New bonds will start forming, all right? Now, because it is breaking, the bonds are breaking and then forming. When the bonds are breaking, it will basically send vibration over the entire surface, right? Vibrational wave it will send over the entire surface of this object, okay? These vibration will slowly stop, will slowly dampen out, and finally it will actually appear as energy, okay? And there will be a force that is needed to maintain this motion as you're actually moving it, okay? So here forms the origin of your friction, okay? All right, so my Hindi is not really good, okay? So what I'm going to do is I'm going to talk very slowly in English, all right? If you don't know, just let me know whatever I'm saying. If you're not able to understand, just let me know. I will rephrase the whole sentence once again, all right? Now, there are different types of frictions, okay? Now, one is called as your static friction. Very simple. Your static friction is a very simple concept, okay? Now, let's say you have a table, okay? On this table over here, what you've done, you are actually kept a block over here. Anything, okay? And any block over here. Think of the objects that's around you on your table or anywhere around you that is at rest, right? This particular object is at rest, okay? Your book that is on your table, your coffee mugs, your glasses, your water bottles that is at rest, anything is fine, okay? That is in contact with another surface, Okay, now what happens is, now let's say to this block over here, you're going to apply some force, right? Let's say I am going to apply a force to it in this direction, meaning I'm going to push this block in this direction. Think of this being a book and I'm just slowly adjusting the book, right? As soon as I push this block over here, there is a force acting on this direction, right? As soon as a force acts in this direction over here, right, what will happen is, this particular force applied, let's say, in this case, whenever whatever force is applied to, for that particular force, an opposing frictional force will be formed, right? Because whenever an object tends to move, there will be a friction force that is forming. This friction force, right, is actually not enough for this particular object to move. So, let's say you're trying to move an object, any object, and if it's not moving, right, you're applying a force, it is not moving yet, okay? Then that point where the object is not moving as you're applying the friction, that particular friction is called as your static friction. Static meaning stationary, or it is at the same point, okay? So the force of friction which comes into play between two bodies before one actually starts moving over the other is called as the static friction. There is a friction force acting opposite to this force applied, but that friction force is equal to the force applied. So this force in this case will not make the object to move. Okay, in this case we can say the static force, this force which is equal to the force applied. This force which is equal to the force applied, this particular force is what we call as static force. Okay, remember static, the word static meaning stationary, right? So whenever static way of force is applied, you think of pushing an object, right, on your floor. You're trying to push some object, okay, and if the object is not even moving, then what happening is the force applied, right, is not as strong enough to your static, it's not as great as your static force, okay, static frictional force. Then in that case, static frictional forces move. Okay, now what you do, you increase the force. Same way, right, you still have the table. On the table you have your book, right, or any objects, right? Very simple. What you're going to do, you're going to more than what you applied on the last case. This time you're going to increase the force over here. Okay, now if you increase the force, what will happen, right? Let's say you're applying a force, you're increasing the force. As you increase the force, there will be a point where this static friction, right, this particular static friction, right, has a maximum force. Okay, now as you keep increasing the force, there will be at one point where the object starts moving. At one particular point, the object will start moving. So the maximum force of static friction which comes into play when a body just starts moving over the surface, okay, that is called as limiting friction. Okay, in this case the object is just started to move. So whenever you're talking about limiting friction, right, we are talking about maximum static friction an object can have, right, or a surface can have, or the two objects that are in contact, right, that surface can have. So limiting friction, okay, limiting friction is nothing but it is equal to your maximum static friction, because at this point the object has just started to move, right? Now at one point what happens, the object starts moving, right? Then the force of friction which comes into play when a body is in a state of motion over the surface of another body, that is called as kinetic or dynamic friction. Okay, once again, let's say you have your table and let's say you have a book over here, right? You apply a force, right, and slowly this book that is over here starts moving. It moves till here, okay, which means it has overcome the static frictional force, and on this case there will be a force acting on this object, but this frictional force that is acting is called as your kinetic friction. we call it as your dynamic friction. Okay, so when this particular force applied, this we can say as Fk, right, kinetic friction. This particular force applied, okay, when this particular force, whatever force you're applying to the object, is equal to this kinetic friction over here, right, or the dynamic friction over here, then we can say the body moves with velocity, right, with the velocity v. Okay, whatever your force is, right, whatever the applied force is, your frictional force will always be in the opposite direction. Let it be the limiting force or your kinetic energy, your kinetic friction or your static friction. It is always in the opposite direction. Okay. Now, if in case you apply a force and this force is greater than this kinetic friction over here, then we can say the force applied in this case is greater than your kinetic friction over here. Okay, which means you're applying a force, with that the body starts going very fast. Right? In that case, we can say the block accelerates. Okay, then we can say the block over here accelerates. Right? Now, this acceleration, we know force is equal to mass into acceleration. Right? In this case, what is the force over here? Whatever is your applied force minus the kinetic friction over here, because one force is, if you see the total force acting on the system, what is the total force acting on the system? That is going to be one force, that is applied force in this direction, and let's say the object is also moves in this direction. Okay, then the object is moving in the direction of the force that you applied, right? So that way, that force minus the kinetic friction is acting in the opposite direction. Minus the kinetic friction is equal to mass into acceleration. From here, you can say this acceleration is equal to force minus the applied force minus the kinetic friction by mass. Right? Now, you can use this formula to find what is the acceleration of an object. Right? Now, in this case, let's see what happens. Okay, let's right? Okay. Okay, quick recap, right? Very simple recap. Let's see, we have an object, right? The object is kept on a table over here, right? And this is in contact with the surface. And now you're going to push the object. As you push the object, you're applying a force on this direction, right? As soon as you apply a force in this direction, there will be a force that exists on the other side, okay? Even though you applied the force, the object is not moving. Okay, you applied a force, it's not moving. Meaning, you can actually conceptualize this in this way. Okay, think of you trying to push your fridge. Okay, you want to move your fridge. Think of you trying to push your fridge. You are applying a force in one direction. This is the direction in which you are applying the force. But the fridge is not moving at all. Why? Because there is a frictional force, static frictional force acting in the opposite direction to the applied force, and the static frictional force is acting equal to this force that you're applying. So, if you take this particular axis to be your applied force, this being your applied force, let's take applied force during the in the x-axis, and let's take your friction force, right, along the y-axis. Okay, so you apply a force, you keep increasing the force. As you're increasing the force, the static friction force is also increasing, which means your object is not moving at all. You push it even more further, right? It is still not moving, which means there is a static friction force produced, which is equal to your applied force. So, initially what we see, as the frictional force, applied force is increasing, the static force is also increasing. Okay, at one time your static force becomes maximum, right? That maximum force is what we call as, so okay, this will be Fs, this is your limiting surface, right? At one point this particular static force will be maximum. Okay, this particular maximum force that we are seeing is actually what we call as the limiting friction. Okay, that we give it as static force maximum. Limiting friction is your static force maximum. So at limiting friction, you know what happens, particularly at limiting friction, these objects, just starts to move. This particular object, it has applied force in this direction. This side, what we are saying is your static limiting friction. Okay, which means the object has started to move. Fs max is your limiting friction. Okay. Now, if it has started to move means right after the object starts moving, now what happens? Your limiting friction, okay, in this case, the applied maximum limiting friction, right? That's the maximum friction, that is the stable opposing force this particular object can give. After that, okay, when this particular force goes less than the applied force, right? Now, you're trying to move slightly, your fridge moves, okay? In that case, what you have is a limiting friction, okay? That is the maximum static friction. Now, after that, as you apply more force, the fridge starts to move, right? So, force is more than the limiting friction, okay? Then what happened? Then the next part, what you have, let's say the object starts moving. Then in the next part, what you have, this gap over here is basically your kinetic or dynamic friction. So, when the object is in motion, it will have kinetic or dynamic friction. When the object is at rest, it has static friction. When the object starts to move, then the maximum static friction it has is called as the limiting friction. Alright. Now, what are your laws for your limiting friction? Okay. In this part that we are seeing over here, what are the laws for your limiting friction? Okay. Very simple point over here. One thing is, this particular limiting friction, right? It depends on, right? It depends on the nature of the surface. Right? Nature of the surface and contact, meaning think that you have kept an object on the table, right? And your table surface is actually rough, right? Let's say you have a very rough table surface and you're trying to push the object over there. Okay? Take the same object, keep it on a very smooth surface, right? Think of a granite surface or something, okay? Or any tile surface or something, and give it a small push. Even if you apply a very small push, the object will still further go, right? It will start moving. So, your limiting force, that is the force in which the object just starts to move, right? That force will depend on the nature of the surfaces in contact. Okay? The rough surface means you have to give more applied force, right? Then again, for you to break that particular limiting surface. So, rough surfaces have more limiting or static friction than your smooth surfaces. Okay. Now, this limiting friction, whenever you're talking about this limiting friction, let's say this is the object. If this is the applied friction, the limiting friction will actually be, limiting friction as your maximum static friction will be in the direction opposite to it. Meaning, it will be in the tangent to this particular two surfaces in contact. This particular surface will be actually in tangent to the two surfaces in contact. Okay. Now, and also if you see, if the direction of the motion of the object is in this direction, okay, applied forces in this direction, this will be the direction of motion, then your contact or your limiting friction will always be in the direction opposite to it. Okay. Now, the limiting friction, if you want to calculate what is the value of your limiting friction, it actually doesn't, it doesn't depend on the area of the surface. How much area of the surface the two objects is in contact with. Okay, it doesn't depend on that. Okay, as long as the normal, that is the reaction forces, as long as the reaction forces are remaining the same between these two surfaces, this particular friction doesn't depend on the depend on your object, right? For any object that you take, there will be a reaction force, right? So this particular object, if you take, right, it will till these reaction, let's say this particular table this particular table has a reaction force for this object on this direction. With the block also will apply a force on this table which is in this direction. As far as these normal forces, if you see, they are balanced. The limiting friction will not depend on the area of contact. Okay. After that, if you see the limiting friction that you're seeing, right, this particular limiting friction, right, that is the maximum static friction. Okay, limiting friction is directly proportional to the normal reaction force. Okay, if there are two surfaces in contact, there will be a reaction force in the opposite direction, right? So this limiting friction is always proportional to this reaction forces. Okay, to remove this proportionality constant, let's remove this proportionality constant and let's bring in a quantity, right? The proportionality constant mu s. Okay, this is called as coefficient. This mu s that we are seeing is called as your coefficient of static friction. Okay, so from here you can say this coefficient of static friction is equal to your limiting friction by your normal reaction force. Okay, now this particular, okay, so this the coefficient of static friction you can define as the ratio of limiting friction to normal friction, right? Coefficient of static friction you can define as ratio of limiting friction to the normal reaction. Okay, so these are we can say these are the laws of your limiting friction. Now, likewise, once the object starts to move, what we have is actually a kinetic friction, right? What will be the value, what are the laws of your kinetic friction? Okay, now the kinetic friction, right? Now let's say you have an object and it is kept on this, and you apply a force, and the force applied, the object starts, this is the direction of the force applied, and the object moves in this direction. Since this is an object that is moving, right, the kinetic friction will be in the opposite direction. Okay, this particular kinetic friction will always oppose the motion of this particular object. So if the object is going in this particular direction, the kinetic force will oppose this. If the object is going in one direction, kinetic force will basically oppose it. Okay, and again, also this particular kinetic friction also depends on the surfaces that are in contact, and it has a constant value. Meaning, if it is a smooth surface, means you can just push, give a light force, and the object will start moving on its own, which means it has very less static friction, and a kinetic friction in this case can be more, right? And if it's a very rough surface, then you have to apply more force for you to break that limiting friction. Okay, and for the kinetic friction may not be more in that case. Okay, so it depends on that surfaces that is in contact. Okay, now kinetic friction also, it doesn't depend on the surfaces that are in contact as far as the normal reaction forces between these two objects, the force that the table exert on the block over here, and the force that the block exert over the table over here, as far as they are actually sort of balanced, right, they remain the same. The kinetic friction in this case, if you see, their value is actually independent over the area, how much surface they are in contact with, it's independent of that area of contact. Okay, next is now the kinetic friction, it will not depend on the velocity of the does not depend on the velocity. Okay, provided the velocity that is given to the object is neither too large nor too small. Okay, in that case it will not depend on the velocity. Okay, now if you want to give the value of this kinetic energy in this case, right, so you can say this kinetic energy is proportional to the reaction forces, just like the earlier case. Now, to remove this proportionality constant, we will introduce a proportionality constant over here. Proportionality sign, we are introducing a constant. Okay, this particular constant is basically, we call this as coefficient of kinetic friction. Okay, now from here we can say kinetic friction is defined as the ratio of coefficient of kinetic friction is defined as the ratio of kinetic friction to the normal reaction force. Okay, so here we can say this is kinetic coefficient of this kinetic friction is basically taken as the ratio of kinetic friction to the normal reaction force. Okay. Now, if in case, right, if you see this particular kinetic friction that has, right, kinetic friction when you're taking, that is the friction that the object has when it is moving, right. This kinetic friction is less than the limiting friction, the static limiting friction or the maximum static friction we have. Okay. Or in other words, if you see from here, you can actually write this Fk as actually coefficient of kinetic friction into this reaction force, right. So over here, if you see, this value is less than in this case static, right, is less than this value over here. Coefficient of kinetic friction into R reaction force is less than coefficient of your coefficient of your static force, limiting force, to that of the reaction force. Okay. So from here we can say the coefficient of kinetic friction is less than the coefficient of your limiting friction. Okay. So or the static friction. Okay. Hello Nick. Right. So this is one thing you can see. So these are the laws of your kinetic and limiting friction. Okay. I hope it is very clear of what we have done, because next class onwards we will start doing more numericals. Okay. Now, what is your, how do we calculate this particular angle of this frictional force? Right. Now, let's say you have an object, you have a table. On the table, let's say you have actually kept a book or a wooden block, anything that you want to take into picture. Okay. Now, what are the, let's do the free body diagram for this particular object. What are the forces that are acting over here? Let's take this to be the origin point O. Okay. The different forces that are acting over here, one is the force that is acting down, that is your weight. Right. So weight of the object will actually will act downwards. So again, weight is nothing but mass into acceleration due to gravity, because these two surfaces are in contact over here, right. So one force, that is the force that is applied on this table, in this case we are seeing as weight. Now, because with what force the object the force that the block over here applies on the table that we have taken as weight, with the same amount of force, the table also will apply a force on this object. Okay, that is basically taken as your reaction force over here, R. Okay. Now what we are doing, there is an object, you're going to apply a force and push it. Okay. So we're going to apply a force in this direction. So the object will start to move in this particular direction over here. Okay. So this is nothing but your, this direction, whatever we have is your applied force. Okay. Now, if this is your applied force, now what will happen? There will be another force acting in this direction over here. Let's say that's the maximum limiting force, static force. That is your maximum limiting force, maximum static force, which is your limiting force, which means the object just starts to move. Okay. In this case, right. So we have two forces that are acting over here, right. One is your reaction force over here, and then is your limiting force over here. Okay. So if you want to find the resultant between these two, what will you do? You have to extend the line over here, and you have to extend the line over here, and according to parallelogram law of vectors, right, you can actually, in this case, adding two vectors, adding these two vectors will produce the same effect as this blue line vector that I've shown over here, right, which is basically your resultant. Okay. Now this resultant makes an angle theta over here with the normal reaction force. Okay. Now this resultant is basically the sum of your limiting force and that of your normal reaction force. This is your resultant. So let me write it as resultant so that we don't get confused. Okay. Now take this part over here. We're going to do little bit of trigonometry, right? So what we're going to say, this side we actually have the resultant. I'm just going to move the vector. This is on this side. I'm just moving it to the other side. Okay. Now this, if you're just flipping this, right, if this goes towards this side, then this comes over here down, right? So this will be your normal reaction force. Okay. Now what we are going to do is this Fs over here, we are going to shift it to this side over here. Okay. And we are going to say this is your limiting force. So that that starts from your resultant, reaction force, and ends at your resultant. Starts at the reaction and ends at your resultant. This is basically your limiting force over here. And this angle that we have shown is theta. Okay. Now, how will we find this particular reaction, right? Theta value over here. If you want the theta value, this is in the sides. This is like a right angle triangle, right? So you have to take two sides. Which angle? Think about it. Which angle can you take for you to take both this reaction force and this limiting force into account? You want this vector and this vector. If you want these two vectors, then you have to take your tan theta, because tan theta will be your base. So your perpendicular by base, right? So from here I can say my tan theta, your tan theta is actually equal to your limiting force over here, right? Limiting force is your maximum static friction, right, by your reaction forces R. Okay. Now we know this limiting force, right? This limiting force by maximum friction R is nothing but your static coefficient of static friction. Okay, so coefficient of static friction is equal to this angle of friction over here. Alright, coefficient of static friction is equal to the angle of friction over here. So from here you can actually say the angle of friction can be defined as the angle which the resultant of the limiting force and the normal reaction force makes with the normal reaction. This angle that is made between the resultant, right? This angle that made between the resultant and this reaction force over here, this is your angle of friction, and this angle of friction is equal to your coefficient of static friction. Alright, now like angle of friction, we also have another concept called as angle of repose. Okay, now right, in this case what we are going to do, what we will do is in this angle of repose, again when we are taking this value, let's see, we still have only a little bit more time, right? Alright, so with this note, what I'll do right now is angle of repose we will actually do in the next class. So before that we will see two more types of forces. Okay, one is your sliding friction. Alright, sliding friction actually means, let's say you have a surface, on the surface you're keeping an object and you're just pushing it. Alright, so this object just starts moving, right? So when this particular object starts moving over here, in this case what is happening? It is sliding. Think of you pushing your refrigerator. What will happen? You're not carrying it, right? You're pushing it. So it is sliding over a surface, right? Now there will be a opposing frictional force that is actually produced, right? This opposing frictional force, when the object slides over one object slides over the other, that is actually called as a sliding friction. Okay, and like your sliding friction, you also have one more, that is basically your rolling friction. Think of your bags, right, which has a rolling wheel, your travel bags which has a rolling wheel, your cart, the shopping cart that has a rolling wheel. Okay, anywhere that has a wheel, right? Then in that case, let's say this is the surface that you're taking, right? Let's say you're taking a surface like this, then actually there is a wheel that we have, right, which will actually roll over this particular surface as we apply a force. In this case also, if you apply forces in this direction, there will be a friction that is actually acting in the opposite direction. But in this case, okay, the force of friction, this force that is acting in the opposite direction, that comes into picture because of one object that rolls over the surface of another object. That is called as your rolling friction. Okay. Now with this note, I'll come towards the end of today's class. So again, if you have any doubts, you can start asking me in the chat box. Okay. Now, Balvi, thank you for that comment. And in this case, till today, right? Today midnight, right? We have a 20% off on your ISC board plus subscription. Okay. If you're taking between July 17 to 22nd, right? Today is 22nd, before midnight if you're taking a plus subscription. If in case you're taking 9 months and above, For example, if you take a 9-month subscription, you will save 2,578 rupees and you're paying only 14,615 rupees. If you're taking 1-year subscription, you are saving 2,975 rupees and you are actually you're paying only 16,863 rupees. This amount you can save. In case if you're taking a 2-year subscription, you're only paying 28,104 rupees and you can save 4,959 rupees. Okay. To avail this particular discount, you have to use my code. You can use my code MTIS10. Alright. So whatever amount, let's say you're paying for 2 years or you're paying for 1 year, this amount, whatever amount you're paying over here, that is for that is for 4 subjects, that is physics, chemistry, math and biology. So physics, we have an ongoing plus batch right now, which is actually started on July 6th. This course is again taught in English. So physics, we meet every Tuesday, Thursday and Saturday for a duration of 1 hour. And for math, you meet, for math, Rahul sir will take, chemistry, Manisha ma'am will take, biology, Lakshay sir will take, and their timings are also given. In case if you are interested, if you take the class 11 subscription, your class 12 subscription is absolutely free. So today if you're taking, if this is the amount you're paying, means your class 12 subscription is actually free. So you pay for 1 year and your class 12 subscription you're getting for free for 4 subjects in this case. Okay, so physics, chemistry, maths and biology. So in a month there will be minimum of at least 10 classes for each subject. Sometimes it goes up to 12 to 14, but 10 for each subject is at least minimum. Okay, and for a month, if you see, minimum 40 classes at least you'll have. Actually, you'll have more than that, but minimum number of classes is at least 40. And every day you will have chemistry followed by physics on Tuesday, Thursday and Saturday. On Monday, Wednesday and Friday you will have biology followed by math. Okay, now in this case, if you see, for class 12 also we have a batch that is going on, Achievers batch. For class 12, we meet every Monday, Wednesday, Friday between 5:15 to 6:15 p.m. Okay, so the other subjects and the teachers are also, again the teachers are same and the other subject timings are also given. Now, the focus of both this Achievers batch as well as Brahmastra batch is your midterm syllabus coverage. So after covering your term 1 syllabus, we move to term 2 syllabus. Alright, so once again, in anything regarding friction, if you have doubt, please start asking the doubts right now. We are also introducing the community feature. The link for the description is given in the, the link for the community is given in my description box. Click on the link, it will take you to my description, it will take you to my community channel. There will be a lot of actually MCQ type question asked for unit 1 and 2. Try attempting them, alright. Unit 3 I'll add very soon. Don't forget, today at 7:45, again we have a class for the same unit, but we will be learning about laws of motion. Don't forget to join the class as well. Now, in case in any of the videos, if you see any inappropriate content and if you're reporting the same, right, you will be claiming, you can claim a prize. And thank you. And like this channel, like and share the video, right? And among your friends, if you like the video, subscribe to the channel so you do not miss out on any of the upcoming classes, and also click on the notification button. All right, and I'll see you all in the next class. Thank you. And I think tomorrow, day after tomorrow, YouTube classes will be around 12 p.m. Right, okay guys, and I'll see you all tomorrow. And don't forget the 7:45 classes we have for class 11 today. Any question again you have on laws of motion, you can come and ask.